Section 16.5 talks about the activity series. The activity series can help us to predict which redox reactions will be spontaneous and which ones won't. So if we take a strip of magnesium metal and we place it in a solution that contains copper ions, we have a chemical reaction that occurs, and we get copper being deposited on the magnesium and magnesium ions forming in the solution. We can see the copper depositing. We can also see that the color is fading. It's not as blue. The blue color over here is from the copper ions. So obviously something is happening. If we do the opposite, same two metals, but we put a strip of copper in a solution of zinc ions, nothing happens. There's no reaction. So why? Why is this? Some metals are more reactive than others. Some are more willing to lose electrons than others are. And so the activity series, which we'll look at in a minute, lists metals in order of decreasing tendency to lose electrons. So the metals at the top are the most likely to lose electrons. Those guys are the most oxidized, and thus they are the most reactive. The metals at the bottom have the least tendency to gain electrons. They're the least reactive. So here's the list. And you do not need to memorize this list. If you need it on an exam, I'll give it to you. So lithium's up at the top and goes down. There's hydrogen in the middle, kind of as a reference, and then there's copper, silver, and gold at the bottom. These are all written as half reactions. So what lithium will do in its half reaction is it'll go to lithium plus and release one electron. That is a loss of electrons. That's an oxidation. There would have to be an accompanying reduction to occur. So the half reactions at the top are the most likely to occur in the forward direction. The reactions at the bottom are most likely to occur if you flip them around. So if you go from gold 3 ion to gold metal, that's likely to occur if it's coupled with something above it. So this is an important thing right here. Let's see, let's get a better color. Right here. Any half reaction on the list is spontaneous when paired with the reverse of any reaction that's below it. So what that means is lithium will react with any of these ions. You'll get an oxidation reduction reaction. Gold will not react with any of them. Like lead here in the middle, lead will react with these ions that are below it. So gold was at the very bottom of that list. It is not reactive at all, and that's one of the reasons that it is so useful as, in jewelry, right? Gold jewelry is nice because it doesn't tarnish. It doesn't react with much of anything. And here's a picture of a bunch of keys, and this gold key is the same age as the rest of them, but it's not all tarnished and corroded like the others are. So typical metals for making jewelry are those that are at the lower end of the activity series. You don't want to make, jewelry out of lithium or sodium that are going to react with water, right? Because then you get a little sweaty and you get this chemical reaction going on and your necklace is gone. That's not good. So let's do an example here. Determine whether each redox reaction is spontaneous. So this first one, we have zinc as a metal reacting with nickel ions to form zinc ions and solid nickel. So I'm going to tell you how I think about the activity series. You guys familiar with Saturday Night Live at all? There was a skit a long time ago. I tried to find it on YouTube. I couldn't. It had Bill Murray in it, which tells you how old it was. But the skit was, ¿Quién es más macho? Who's more macho? And the whole thing was done in Spanish. It was hysterical. So, ¿quién es más macho, Fernando Lamas or Ricardo Montalban? And I believe the answer was Fernando Lamas es muy más macho. And for some reason, it was just hysterical. It's not funny today, is it? But muy más macho. And so this is a list of the macho guys. And Lithium is muy más macho. He is the most reactive. And Gold down here is not very macho at all. And so do you remember I talked about those single replacement reactions as a guy going to a party by himself and stealing somebody else's date? So in this reaction here, is nickel 2+ ion all by itself in that solution, or does it have an anion with it? It's got an anion, right? So let's just pretend it's chloride. So this would be nickel chloride. Zinc plus nickel chloride going to zinc chloride plus nickel. So if we look at this list, this is the macho list. There's zinc. There's zinc. And here's nickel. ¿Quién es más macho? Zinc, right? You also think of this as maybe a list that the popular girls kept of the guys in the senior class, you know, and Lithium was the best one, and you'd really want to go out with him. And it was decreasing order of desirability. So zinc is more reactive than nickel. Zinc is more macho than nickel. So when zinc shows up at this party, chlorine drops nickel and takes off with him. And poor nickel is left going home by himself. So that's the non-scientific way of doing this. The scientific way is we look at zinc. Zinc going from the metal to the ion is the forward reaction. And zinc is above nickel. So zinc will react with the ion of any of the metals underneath. Because what we have here is we've got nickel plus 2 electrons, and we've got zinc going to zinc 2+ plus 2 electrons. This is the forward reaction that it was talking about, and this is reversed, right? Because the forward would be the metal reacting to form the ions. Because zinc is above nickel, this reaction will occur. Any questions? It's spontaneous. Mm-hmm. It will happen. If you stick zinc metal in a solution that contains nickel ions, a reaction will occur. If you stick nickel metal in a solution of zinc ions, the reverse reaction, nothing will happen. What about zinc and calcium? Is this reaction going to happen? ¿Quién es más macho? Calcium. Calcium is way up here. He's third on the list. Right there. And here's zinc. So zinc can only react with an ion of a metal below him. This isn't going to happen. Zinc is not cool enough to steal calcium's girl. So this one is spontaneous. And this one is not. Any questions?
So then for it to be spontaneous, the first element would need to be reacting with an element below it on the list.
The one that's a metal The one that's an element, not an ion, has to be higher. Yeah. Because if I just wrote this in the reverse order, Ca2 plus zinc, that's not going to make it happen. You look at the metal. So this is the guy by himself. Here, this guy already has the girl. He's in a relationship. Okay? And so because zinc is not as macho, I lost here, there's zinc, not as macho as calcium, he can't take the girl away from calcium. And so he's just left by himself. Nothing happens. Any other questions? The quien es más macho thing has worked for me for years and years and years. It just, I don't know, it makes sense to me. Maybe my mind's a little twisted. I'm probably sure that it is. That list can also help us to identify which metals will dissolve in acids. Most acids dissolve metals by the reduction of hydrogen ions to hydrogen gas. And then the metal gets oxidized to its ion. So metals that are above hydrogen on the activity series will dissolve in acids, and metals below hydrogen do not dissolve in acids. There's one important exception, and that is nitric acid. Nitric acid does dissolve some of the metals below it, but that's because it does so by a different half reaction. It's not hydrogen being reduced to H2. But this is the sort of thing that you see when a metal's dissolving in acid. Here's zinc metal, and here's the zinc reacting with hydrogen ions. The hydrogen is going from a +1 oxidation number to a 0. It's being reduced. The zinc is going from 0 to +2. It's being oxidized. When we look at the list, here's hydrogen, and here's zinc. So zinc is más macho than hydrogen. So zinc will react with the hydrogen ion. So will silver dissolve in hydrobromic acid? You have to look at the list. So here's H2, and here's silver. ¿Quién es más macho? The hydrogen is. So silver metal will not dissolve in acid, because the forward reaction for this one is H2 going to 2H plus 2 electrons. The forward reaction for this one is silver going to silver plus 1 electron. This reaction wins. The one on top wins. So this one gets flipped around. And hydrogen can reduce silver ions, but acid cannot oxidize silver metal. So the answer is no. It's important that it says hydrobromic acid there. It will not dissolve in anything but nitric acid. It might dissolve in nitric acid.